Hi everyone, welcome to my channel. My name is Fikret. In one of the recent videos, we have talked in great detail about Spark structured streaming, which is one of the Databricks real-time analytics technologies. Although Spark structured streaming can ingest from many different sources, including storage locations, there is one flavor of this technology which has lots of great feature for files located in storage locations. So today we're going to discuss Spark structured streaming special flavor called Autoloader. Autoloader has quite few great features which will free data engineering from building some of the custom data engineering logics. And the great news is that you can use it not only for building real-time pipelines, but you can also use it for traditional ELT type of pipelines, which expects the data from storage locations. I'm excited to take you to that journey. So here are the topics that I'm going to cover today. We'll start with the overview of Autoloader, where I'll explain its main purpose, advantages, syntax, and sources from which it can ingest. Next, we're gonna have a quick setup session where I'll explain how to set up your environment in case you would like to repeat demo exercises. In a demo section, we will first start exploring different Schema Evolution options available with Autoloader. So in my view, Schema Evolution is one of the features that makes Autoloader great because it has quite few flexible options which you would otherwise will need to build yourself. Next, we're going to talk about Schema Inference, which allows you to infer data types in your input data sets. Then we'll move on to discuss file discovery and the notification modes. And finally, we will wrap up with exploring some other common configuration options. A few quick notes here. So as I mentioned, Autoloader is based on Spark structured streaming, and you will understand this material better if you are already familiar with Spark structured streaming basics. So I'll post a video in the description of this video in case you would like to take a look. Also, if you are new to the channel, please subscribe and provide feedback. Your support and feedback is very valuable to me. Let's get started. So what is Autoloader? Autoloader is one of the sources for Spark structured streaming. When you specify format as cloud files, structured streaming switches to Autoloader mode. In terms of sources, Autoloader can read from all three big cloud data providers. So it can read from Amazon S3, Azure Data Lake Storage Gen 2. It can also read from Azure Blob Storage, and finally it can read files from Google Cloud Storage. So Autoloader has many different configuration options, and one of the key configuration options is a format method where you have to specify cloud files. Besides this, there are also some other important options like cloudfiles.format, which tells what are the file formats that you are trying to ingest, as well as schema location, where Autoloader will create schema which it will infer based on your data. Finally, you can call Autoloader both from Python and SQL. So I have provided SQL syntax here at the bottom. And we will explore both options in a demo. Now, I already mentioned some of the advantages. So Autoloader has high scalability, designed to quickly discover lots of files arriving to your storage. Great file discovery and the notification systems that we're going to explore shortly. It allows you to ingest data asynchronously. Autoloader has flexible schema evolution options, which allows you to change schema management based on your needs. Finally, Autoloader is cost-effective service. It discovers and ingests the files using relatively low-cost services. Okay, so let me explain you how you can set up your environment in case you would like to run demo exercises in your system. First of all, you will need to have a Unity catalog. That Unity catalog will host your structured and unstructured data. So first of all, you'll need to create volumes for unstructured files. Spark structure streaming requires a checkpoint in location, and the Databricks recommends that you create external volume for that. However, you can also use standard volume for the purpose of checkpointing. So in my case, I have called it external landing volume, and you will need to have a volume to host the files that will be generated by one of the notebooks. So I have called it landing. Once you have provisioned these two volumes, make sure that you copy their respective paths somewhere, which we'll need shortly as part of notebook localization. If you don't have Unity catalog in your workspace, you can also use a default Hive metastore for that. However, to store your unstructured files like checkpoints, as well as the data files generated by the system, you will need to specify either DBFS location or some other locations to which you can write into. And in terms of structured data, so demo code will create tables which will go on the tables sections. So you don't need to worry about that. All you need is to have a relevant schema for that. Now let's talk about code. So one of the notebooks that I share will be responsible for generating input files. So that notebook is called Generate Streaming Data Autoloader. So let me walk you through this notebook. So we have a number of utility functions in it. Prepare data will create necessary folders within the data volumes that you specify as an argument. Drop all tables function is optional. It will clean up the environment if you want to rerun the demo exercise multiple times. Reset checkpoints functions works similar way. It just cleans up checkpointing locations for streaming. And the reset environment will combine all these three functions. Then there are some utility functions that you don't need to worry about that. Important functions here from user perspective are generate persist streaming data, which will generate IoT measurements data, and similar functions with enhance added to its name. So only difference between these two is that the enhanced version of the function will include few extra columns, which will help us when we explore schema evolution options. You can call these functions right from this notebook or from the demo notebook itself. So if you want to call it from here, you will need to specify a root folder, which again will come from this volume. And at the bottom of this notebook, you will find commented sample calls to these two functions. Now let's talk about demo exercise notebook. So demo exercise notebook includes the data generation notebook at the beginning, as you can see. So that would allow us to call the utility function from that notebook. And here are some of the localizations that needs to be applied to this notebook. First of all, you will need to put your Unity catalog name here in command 4. And the code will take care of creating this schema. Then you will need to provide root data folder in command 5, you'll also need to provide streaming checkpointing volume in line 3 of command 5, like this. And that's all that's required from localization perspective. Let me know if you encounter any technical issues on setting up your environment. Alright, let's start by creating a simple autoloader pipeline. I'm in my demo notebook and I already run top few commands to prepare the environment. And most importantly, I have run command 6, which would generate a sample dataset. This dataset has no irregularities. All of the files follow the same schema. And now I can run command 9, which will create streaming data frame. So this command by itself will not initiate the stream, but we can inspect this data frame's structure. If we want to see a sample data from this stream, we can use display command. And this is how my data will look like. So as I mentioned, this is a IoT measurement data. We have event timestamp here. We have measurement type, measurement value, office, and the sensor columns. We also have rescued data, which is not part of the input files, but was created by Autoloader. Right now it's empty because we don't have any irregularities. So let me cancel this stream. And now let's move on to creating end-to-end streaming pipeline. Command 10 starts by creating reading stream data frame, but then I am using write stream API to write in the destination. Notice that I am using checkpoint location here. I also specify destination table where all the data will go to. So let's start this stream as well. When you start any streaming pipeline, the first step is initialization. And as soon as it's complete, you will see the icon at the bottom of this command changing to something like this, which indicates that streaming is on the way. So now we can expand this and take a look at some ingestion statistics. So we have input versus processing rate. So input rate indicates how quickly your data source receives the data, and the processing rate is how quickly your Spark process is able to process. You also have batch duration chart here. In a stream dedicated tutorial, I mentioned that streaming in a typical configuration is series of micro batches, and this micro batch duration can be controlled if needed. So in this case, we can see high micro batch duration, which drops over time. All right, once we have this stream running for some time, we can go ahead and inspect the data in the destination table. All right, now let's take a look at similar command with SQL syntax. So in command 12, I am using select statement with read files function, which should generate similar streaming. So let's talk about Autoloader's Schema Evolution features. So first of all, what is Schema Evolution? Schema Evolution is the ability of your system to adapt to ever-changing structure of your input files. So those of you who have built ingestion pipelines know that input file structures are rarely static. So you may build your system assuming a certain schema for your input files. However, you may discover that a few months later you get different schema. So some of the files may have more columns or less columns, or sometimes column names are different. A well-designed engineering pipeline should be able to adapt to these scenarios. So let's see what schema evolution options we have in Autoloader. When we are talking about streaming pipelines, schema evolution options, we have to differentiate two sets of configurations. The sets of configurations that are relevant to the reading part. So Spark Structure Streaming is using readStream API, as you know, and you can supply a number of configuration parameters for readStream data frame. And to define configuration options for schema evolution, you can specify cloudfiles.schemaEvolution mode option. There are 4 schema evolution options that you can specify with that. Add new columns option is a default option. With this option, your streaming pipelines will fail when it starts ingesting files which have different schemas that it expects. However, if you re-execute the streaming pipeline, it will resume from the point it has failed on and will add extra columns to the target schema. With rescue options, any new columns will be added to a special column that you specify as a configuration, which will allow you to inspect this data and act based on that accordingly. A fail on new columns options is self-descriptive, so it will cause your pipeline to fail, and it will keep failing if you try to resume the streaming. And with the none option, your pipeline will ignore any new changes and continue ingesting data that complies to the expected schema. Now let's talk about the right part of the pipeline, because streaming pipeline, as you know, has read part and the write part. So the adaptive schema evolution options that I have mentioned earlier will work only if you set merge schema option to true. All right, let's now explore different schema evolution options. In command 17, I am resetting environment and generating the sample data again. And I have similar autoloader pipeline, except I am specifying schema evolution option for this pipeline as add new columns. Again, add new columns option is a default option. So to get the behaviors that I'm going to demonstrate here, you don't really need to specify this. Otherwise, my pipelines is similar to what we have seen earlier. So let me run this pipeline. Another thing to notice here is that I am using merge schema. I am setting merge schema option to true when writing into the destination table. That's because I'm expecting some schema irregularities. Okay, now that we have our autoloader stream running, let me generate some irregular data. This function with enhanced postfix added will generate similar data, but with extra pressure column. So if I run this command, now I have files with 2 different schemas. And if I go back and check my streaming pipeline, I can see that it has been terminated. So if we take a look at the details of the error, we can see that it's complaining about that extra pressure column. And it also suggests that this issue will be auto-fixed if we resume the streaming. So I'm going to rerun this pipeline. And now this stream succeeds. So now let me browse the content of the destination table. Now we can see that we have this extra pressure column added to my table. All right, now let's take a look at another option. So now we're gonna explore failOnNewColumns option. Before creating second pipeline, let me reset the environment and regenerate the data. And here in command 24, I have similar autoloader pipeline, except I have failOnNewColumns option specified as a configuration. So let's run this pipeline, and I'm gonna scroll down and find the command which will generate files with additional column, just like we did before. And if we go back to the streaming pipeline, we can see that it failed with similar error message, and it tells that automatic retry will not fix the issue. So let's rerun the command again. Now it fails permanently. Okay, now let's explore the next option called rescue. I'm gonna reset the environment again and generate the files with a simple structure. And then we'll run another streaming pipeline, this time with rescue configuration option. Once my streaming pipeline has started running, I'm gonna go to command 31 and introduce irregularities again to the same folder. And let's go back and see what happens to our streaming pipeline. So as you can see, the streaming pipeline did not fail this time. Now, if we take a look at the destination table, we can see that there are rows with non-empty rescued data. So let's take a look at one example. So this column includes information about the column that violated the expected schema, as well as file names that contain these rows. So having this kind of information would allow you to go back and troubleshoot any data irregularities without having your pipeline to fail. Finally, let's take a look at non-Schema Evolution option. I'm gonna reset the environment again and start my Autoloader pipeline. And while my streaming is on the way, I'm gonna generate schema irregularities. And let's see what happens to the streaming pipeline. So now we have got irregular files in our folder. However, as you can see, Autoloader pipeline did not fail. Now let's take a look at the destination table. So as you can see, Spark has completely ignored an extra column coming from irregular files. Now let's talk about Schema Inference options with Autoloader. So Schema Inference is a feature which allows you to infer the schema based on the sample data in your files. If you specify Schema Inference, Spark will infer the schema based on the first 1000 files or 50 gigabyte of file volumes, whichever comes first. And to turn this option on, you can use cloudfiles.infer column types setting to true. There is another schema management option with Autoloader, which allows you to specify exact schema that's expected. And to do that, you can use cloudfiles.schema hints and specify string, which will include column types. Now let's see how Schema Inference works in practice. So this is a data set that I have ingested into my destination table. As you can see, all columns are string type. And that's because data is coming from JSON files which do not contain column type information. And by default, when Autoloader receives the data from files like JSON, CSV, it will assign string data type to all columns. Now let's explore this option. So in command 39, I am using default option, which causes no data type inference. So if I run this command, we'll see that all columns are string type. So to fix this problem, I'm gonna set infer column types configuration to true in command 40, and let's see how the schema of my data has changed. So as you can see, Spark was able to figure out correct data type for measurement value column based on a sample data. All right, now let's explore schema hints configuration. So in command 41, I am using schema hints method to tell Spark exact data types I am expecting for certain columns. So in this case, I am telling event time should be timestamp and the pressure should be double. So let's run this pipeline as well. And here is my stream content with correct data types. Now let's talk about file discovery and the notifications mode with Autoloader. So as I mentioned, Autoloader is very efficient on discovering new files, and it can easily process thousands of files quickly arriving to your storage. And the Autoloader uses two main methods to discover files. The default mode is a directory mode, which is very good for discovering files arriving in many different folders. The best use case for this option is partitioned files. So as you may know, many different systems, when writing to the storage locations, may optionally use partitions. And when you specify partitions, files will be written in many different folders in parallel. So the directory mode of Autoloader is very efficient to read files written in that manner. The alternative option is file notification option, which is great if you have fewer folders containing lots of files. So, however, keep in mind that this mode requires greater permissions. So I have provided requirements that are relevant to Azure Data Lake storage here. So first of all, you have to provision a service principal. Then you have to grant permissions for that service principal on storage levels. So I have listed here two key permissions, so contributor and the storage queue data contributor permissions. And then you have to grant resource group, which contains your storage account, event grid, event subscription contributor permission. All right, now let's explore different file discovery and notification options. So in command 43, I am using directory mode, which is the simplest and the default mode to discover the files. So this will create Autoloader pipeline just like the ones we have been using earlier. Notice that to achieve this, I am setting use notification setting to false. Now let's explore file notification option. As I mentioned earlier, this configuration requires quite a bit of Azure setup. So in command 45, I am assigned different Azure settings to variables. So in this case, I receive subscription ID, tenant ID, application ID, application secret, as well as resource group name. I'm going to explain how to get these values in a moment. So most of these values are related to storage account from which I am expecting my data from. So I have created ADLS Gen 2 account. And from here, I can get my subscription ID. Next three values are related to service principal. To create a service principal, you have to navigate to application registration in your Azure subscription. And from there, create new application registration. So you can come here, application registration, new registration, and that will give you application ID as well as tenant ID. So here's my application ID and tenant ID. As soon as you create new application, you'll be able to generate the secret. It's not recommended to store all this information in your notebook. The best practice is to store it in your key vault. Finally, you can take resource group from your storage account properties as well. All right, now that we have discussed how to receive all of these Azure settings, the rest is really easy. So in command 46, I am creating a dictionary and assigning all these variables to different Autoloader configuration properties. And then in command 47, I am using this configuration settings in line 8. Most importantly, I am turning use notification settings to true to indicate file notification mode. Another important part of these configurations is Azure permissions that needs to be granted to the service principal. Let me walk you through the permissions settings as well. So here is my storage account, and to set permissions, I will navigate to Access Control tab and use Add Role Assignment command here. I'm gonna show you roles that I have assigned for my account. So this is my service principal that I am using for Databricks ingestion. So if I filter by its name, we can see the permissions assigned to that. So as you can see, I have assigned contributor permission. I have also assigned storage queue data contributor. The last permission that needs to be set up is on resource group level rather than on storage level. So let me find out my resource group, and I'll navigate to Access Control tab again and take a look at role assignment. So as you can see, I have assigned event greet, event subscription permission to my resource group. With these 3 permissions, file notification in Autoloader should work. All right, let me wrap up this discussion with brief description of some other common Autoloader configuration options. Include existing files option allows you to turn on or turn off processing of historical files. When I say historical files, I mean files that pre-existed before your Autoloader streaming pipeline has started. So by default, it's set to true, meaning that your existing files will be processed alongside with new arriving files. However, you can turn it off, which means that only new files will be processed by Autoloader. Modified before and modified after options can allow you fine-tune interval for which you want to ingest existing files, and their names are self-descriptive. A backfill interval also allows you to change processing of your existing files. So you can set different time interval for this. Either you can set 1 day or 1 week. And at that interval, Autoloader will go back and process any unprocessed files. Finally, max files per trigger and max bytes per trigger. These are more of performance-related configuration options. So they tell you how many files or how much data volume per each streaming microbatch Autoloader is going to ingest. You will also find few examples of using include existing files as well as modified before configuration option. at the bottom of the demo notebook, so feel free to play with these commands as needed. Alright, that's all I wanted to cover today. To sum it up, we have explored basic usage of Autoloader. Then we have looked into some of the advanced configurations features like Schema Evolution, Schema Inference. Finally, we have explored different file notifications and the discovery modes available with Autoloader. I hope this discussion was helpful. I'm looking to get your comments and the feedback on the usage of Autoloader. Thanks for watching, and I'll see you in future videos.